Okay, let's put these problem-solving steps and setting up a word problem to use in problem 7-33. So, step one, first draw a diagram. Okay, we're going to draw a diagram. A man 6 feet tall walking at 4 feet per second directly away from a light 10 feet above the ground. So, let's sketch the situation. Here's my light, 10 feet above the ground. Oh, the light here. Here's the ground. There's a man walking away from there. And here's the light shining on him. Now, where would the shadow be? That's one of the tough things for some people to picture, but the shadow would be cast right here as the light went past him and his body blocked the light from this area right here. So let's go ahead and make up some variables. Second step, name and define the variables involved in the problem. So I'm going to go ahead and say S for length in feet of shadow. Shadow. S for shadow. Now, it doesn't really matter what variables you use, what letters you use, but it is easier if you use something that makes you think of what you're talking about. Then you don't have to rely so much on the key, but this is pretty important. Okay, and then we're also talking about time in seconds, so let's call T time in seconds. Okay, so let's get started with problem A. A, how long is the man's shadow when he is 20 feet away from the light? So, third step, write and simplify equations that relate the different variables. Okay, so here's a variable right here that we actually have some information on. This is 20. The man is 20 feet away from the light. So let's plug that in. And what we've got going on here is some proportional triangles. Oh, I also need to label the man's height, 6 feet. I've got two right triangles, a large one and a small one. The large one, we've got 10 for the height, and the total here is S plus 20. And the man's height is the height of the smaller triangle, and S. So we can set up a proportion with that. The height of the man, 6 feet, to the height of the pole, 10, is as the length of the small triangle to the length of the larger triangle. And we can use cross products to set this up and simplify. So 10 times S equals 6 times S plus 20. We need to remember to distribute, so that's 6S plus 6 times 20, which is 120. Now let's subtract 6S from both sides, and we get 4S is equal to 20, and so our shadow length turns out to be 5 feet. Oops, I forgot to write the 120, so 120 divided by 4, our shadow length is more like 30 feet. Here we go, that looks better. Now let's see about question B. How long is the man's shadow T seconds after he starts? The answer will be in terms of T. Okay, so at this point we don't really know what this distance is, but we do know that there's a relationship between distance, rate, and time. I like to call them dirt problems because distance equals rate times time, and if I squint my eyes and I'm creative, this looks like it says dirt. So that's how I remember. So this distance right here is going to be my rate times my time. My time is unknown, t seconds, but I know my rate is 4 feet per second. So this distance for the second problem will be 4t. We're going to be able to set up the problem the same way. Instead of 20, we've got 4t. So we can proceed as in the previous problem. So 6 to 10 is now equal to s over s plus 4t. So cross products, 10s equals 6s plus 24t. Subtract 6 from both sides. We've got 4s is equal to 24t. Now let's see what we want to do here. It says the answer will be in terms of t, and we're trying to find the length of the shadow. So the length of the shadow is what we want to find. So I'm going to solve this for s. So the length of the, by dividing by 4, so the length of the shadow is 6t. So using this, we can figure how long his shadow is no matter how long he's been walking. So at 6 seconds, we would have 6 times 6, so 36 feet would be the length of the shadow. After 10 seconds, the shadow would be 60 feet in length, and so on. So there we go. Now let's give a try to the next problem. See you in the next video.